Hi everyone, welcome back to Stefan Livera podcast, brought to you by swan.com, the best place to buy Bitcoin. Joining me today to talk about silent payments are Josibake and also Ruben Somsen. So welcome back to the show, Josie and Ruben, first time.
Yep. Hi.
I think it's the second time for me. And as I was pulling out the microphone and setting up in the kitchen, I was like, I think the last time I touched this microphone was 2 years ago when I talked with you about education, I think.
Yeah, I think I remember that episode. We'll link that in the show notes for people who want to go back and revisit that one. And so yeah, let's talk a little bit about silent payments. There's been a bit more noise about this. Obviously, there's been a bit of conversation about Bitcoin needs more privacy on chain, and so I guess that's driving some of this. So maybe Josie, do you want to just give us like a kind of 1 minute overview, just for people who want the kind of 1 minute TLDR here?
Yeah, so silent payments is BIP 352, and it's a proposal for reusable addresses in Bitcoin. So something that you can post publicly to like accept donations that I could give to you. If you're like, I'm getting paid in Bitcoin and I need 12 payments over the course of the year. I just give you that one address and you can reuse it to send me stuff. And, we talk a lot about on-chain privacy, but this is even more just like a step above on-chain, I would say, where nothing on-chain is really changing with silent payments, but we're more getting some better usability and privacy in that layer of how do I communicate to you how I want to be paid. And as we know, with traditional Bitcoin addresses, we're not supposed to reuse them. And we're also not supposed to even post them publicly, because as soon as you post a Taproot address or a SegWit address somewhere, anyone can just look it up in a block explorer. So silent payments is trying to address that area right there of how do we communicate the instructions of how we want to be paid in a private way, and also a way that I would say has good user experience.
Yeah, so one thing I would add to that is essentially, I mean, it's almost the same as what Josie said, but like it really is that we currently sort of have this two bad choices. We have the choice of either you have to interactively, every time you want to send a payment, you have to receive an address, or you have to reuse your address and then everybody can see how much money you received. And I would say that this is basically, it makes Bitcoin work like the average newbie would think it works, which is just like a bank account where you have a bank account number and people can send money to it. And then that would be sufficient for you to receive money in a way that nobody else knows how much money you received. But in Bitcoin, it doesn't work like that. You need to create a new address every time. And now that's no longer necessary while you can still maintain privacy with silent payments. And so it simplifies the UX in a way that still maintains privacy, essentially.
Gotcha. Yeah, that's a good point to make for listeners who are maybe not as into the detail. Let's get into a little bit of the history of this idea. I think, Ruben, you'll probably be best placed to explain a little bit. There are other ideas out there. I know a lot of people might be familiar with, or they might have heard of Bit47, and they might have used, let's say, Samurai Wallet or Sparrow Wallet with Paynims. How does this idea sort of compare with other ideas out there?
Yeah, so it is actually a very old idea, right? Like it originates from the stealth address idea, which is basically there's a very like old cryptographic trick, which basically allows two people who have a key to generate a shared secret. So it's something that only the two of them know. And you can use this to essentially generate what you could consider a 2 of 2 multi-sig address, where one of the keys is known by the sender and the recipient, and the second key is known only by the recipient. And so effectively, it just means it becomes a recipient key because the recipient knows both of the keys. And so this stealth address trick has been known for a long time, has been discussed for a long time. Like I think back in 2012 already, like people were saying like, oh yeah, we could use this for Bitcoin. But it never really quite came together in a way that was fully elegant. So I think Peter Todd's stealth address proposal essentially required you to put another key on chain in either op return or something. And so that would do two things. Like one, it would make it so that it was very obvious that you were making a stealth address payment because it had this op return data. And so you would be able to distinguish it from any non-stealth address payments. And so that's bad for anonymity. And it's just on-chain inefficient, right? So you have to add extra data, so it's more costly to make a payment like that. Then the sort of second idea that really was, I think, already thought of back then was like, hey, why don't we use one of the keys that are already in the transaction and do it that way? But that never really gained any ground, basically for a couple of reasons. I would say one, at the time, it was seen to be just a little bit too complicated. Also, we didn't have libsecp at the time, which is basically the library that now does all the cryptography. And that's at like 6-7x improvements over like how fast doing these calculations used to be. So it was sort of considered like too expensive of an operation to add to Bitcoin. And so the idea sort of died down and nobody really did anything with it. Then came along BIP47, which basically said like, okay, look, maybe we can do a little bit. We add some data to the blockchain, but we're not going to do it with every time you make a payment. And so instead, what BIP47 chooses to do is say like, okay, we're going to create a notification. We're going to put some data on chain once. And that data will be recognized by the recipient, and then the recipient will basically know what secret to pay attention to. And then in the future, you're going to use that secret to make repeated payments to them. And so the nice thing about this is that it's very clear to the recipient what they have to do. They don't have to check everything on chain. They just see a message that belongs to them, and then they're like, okay, I'll pay attention to that. The downside, I would say, is a couple of things. For one, the UX on the sender side is quite difficult because now you have to, before you make a payment to someone, you first have to make a notification to them, and that's another on-chain transaction. And I think especially if fees start to go higher, that'll be a little awkward. But also UX-wise, it's just a little difficult. It's more on-chain data, which is sort of considered not very elegant. Anytime you use the Bitcoin blockchain to, essentially what you're doing is you're notifying one specific person about something that is not directly about a payment. So it's sort of like, okay, well, that seems like a wasteful use of block space. And another big thing is that it links the payments. You reveal to the recipient when you're making repeated payments as a sender. So if I were to use BIP47 and would pay you multiple times, then you would, you'd see two things. The main thing you would see is, okay, somebody paid you multiple times, whereas with silent payments, you wouldn't be able to recognize that it's the same person paying you multiple times. And the other thing is that with BIP47, although this would be solvable if you use another BIP, with BIP47, in the notification transaction, I actually reveal my payment code, my BIP47 payment code. So I'm actually revealing my identity as well to the recipient, which is not great. Like if you didn't want that to happen, then now you don't necessarily want to have the recipient know who you are as a sender, especially let's say you're donating to a cause and it's somewhat controversial, and now they have data about you that could leak. You wouldn't necessarily want that. So I would say those are sort of the differences. And of course, like I think this is already like a little bit going to the weeds because we're making these comparisons and we're talking about technical things. But the one downside that silent payments have over BIP47 is that there's a scanning requirement. So you have to essentially pay attention to the blockchain, do some extra calculations, and figure out whether or not you got paid. If you run a full node already, the cost of that is essentially zero, and we have a lot of optimizations for like clients as well that make it pretty viable. So I think that's probably we'll be discussing that further on.
Okay, so let me just list out a few of the things there. So just to, because that was a lot there, so just to make sure everyone's following along. So there, in the BIP47 style that's widely adopted, there's a notification transaction. As you said, the recipient knows if the sender is doing multiple payments, which maybe they don't want that, and the recipient can connect those payments back to a particular individual in certain cases, or a particular identity, to be clear. And there's also an argument around worse on-chain efficiency. Now, the downside as well, as you mentioned, to be fair, is the computational expensiveness, right? It's more computationally expensive, and so maybe would that make it more difficult to sort of run, let's say, like a public Electrum server or something like this kind of infrastructure if lots of those people want to also use silent payments?
Yeah, I think before I answer the Electrum question, I think one thing that's been really interesting to me and how I think of like the narrative arc from like the earliest stealth address to where we are now, you have this thing of bandwidth and computation. And in the early days of Bitcoin, computation was the most precious resource. Like even calculating a signature, verifying a signature was an expensive operation. Doing elliptic curve operations were expensive. And on-chain was basically free, right? People were relaying zero-fee transactions. People were worried about people filling up the blockchain because there wasn't enough demand for it. And so for all intents and purposes, like on-chain was not really that scarce of a resource. And it's interesting when you look at it in that framework, because you see the original proposal with stealth addresses, they were like, let's just put an ephemeral encrypted key into every single transaction in an op return, because on-chain is free. We're going to use op returns for all kinds of stuff. And then later on, you had Bit47 and other proposals, which I'll just call the notification style proposals. And they're like, okay, well, no, we really can't put an op return in every single transaction, because now on-chain is getting more expensive. So it's okay, we'll establish a payment channel. So we go from a piece of data in every single transaction to a piece of data per counterparty, right? So Bit47 and other notification style ones, you establish a payment channel with every person that you're going to expect to have repeat payment. So we've gone from data in every transaction to data per every counterparty. But on-chain has continued to become more expensive and more scarce of a resource, to the point where I see silent payments as the next evolution of that. It's like, what if we could get rid of that completely? Now we don't even need the on-chain space per counterparty, and we can just make it just the transaction itself. Now, at the same time, every time we've made this trade-off on space, we've necessarily got to do some more computation. It was the same with, stealth addresses to Bit47. With Bit47, there's some more computation they're doing on the client. And with silent payments, I think we're just continuing to follow in that, where there is more computation on the silent payment side, but what we're getting rid of is all of the on-chain space requirement. And if we keep thinking about the trajectory of where Bitcoin's going to go in the future, I would argue that on-chain space is going to continue to get more and more expensive, whereas computation is going to get better and better and better. And we've already seen that with, like Ruben mentioned, libsecp, but even just CPUs and processors on phones and everything like that. We're getting to this point now where if I can design a very simple protocol and just throw compute at it, that's going to be far better than coming up with all these tricks and more complexity to avoid just spending the CPU power. Because the CPU power is more abundant, the space and the complexity and all these other trade-offs that kind of the earlier protocols were making, I think we're outgrowing those approaches. I think they were great at the time. And, Bit47 made a lot of sense. Even stealth addresses made a lot of sense back when like compute was very expensive and Bitcoin block space was basically free. But as we've kind of moved into this era now where that's flipping, I don't even really see these as competing proposals anymore. I just see it as the evolution of, like, as on-chain space gets more and more expensive, we're naturally going to have to migrate to things that are far more space efficient and potentially make that sacrifice by just throwing a whole lot of compute at the problem.
Yeah, really good points. And so I would summarize, I think, the other, as we've kind of broadly talking about it, obviously we've mentioned these, but the kind of big wins I see are this idea that you can have a static QR, but it's actually not reusing addresses. And it kind of, as you were saying, Josie, I think in some online discussions, it's like we can kind of bring this idea of a Bitcoin username. And it's not exactly that, but it kind of is that. And so then whenever people are doing on-chain payments, now it's like, it's a much simpler UX. Instead of me going to ask Ruben or ask Josie, hey, give me your address and let me pay you. Now it's more like, it's kind of like having a contact list and a contact that you can just reuse. And so that's really useful. So do you want to just touch on where things are at right now with silent payments in terms of wallet support? And just to kind of explain, this is not a consensus change. This is something that's happening at the wallet, in wallets.
Yeah, so I can speak to that because that's where I've been the most active. So, to your point about a consensus change, this is just a wallet protocol, right? Like it's something that it's a protocol for different wallets to communicate with each other. We could say application layer, right? We're not talking about anything in Bitcoin's consensus here, which is kind of nice, right? I always get excited when there are these opportunities to improve the usability and the privacy of Bitcoin without needing to get the entire Bitcoin community to agree with you. And so this has been kind of a fun one, I think. So in terms of status, Ruben proposed the original idea back in like March 2022. I heard about it in like October 2022, got involved, and then we sat down and like, okay, let's write a BIP. Let's start working on implementations. The BIP was just recently merged. I would say it's been ready-ish for like 6 months, maybe 4 months with like minor tweaks. But it's merged in the BIP repo right now. And so, having a BIP merge just means like we're considering the spec final enough to start building on. Maybe as people start building, we're going to notice oversights or little things that need to be tweaked and fixed, whatever. But having the BIP in kind of like the merged, like ready to go status is a signal to wallet developers, hey, this is ready to build. Like you guys can start building this and using this. So we've got that. The BIP's got test vectors that wallets can use for implementing it, etc. So even before the BIP was merged, I was working on an implementation for Bitcoin Core because that's the code base I'm most familiar with. That's the wallet that I use. And it's also, with the Bitcoin Core approach, I've got PRs open for send and receive support for Bitcoin Core, but we're also looking at building a light client index. So an index in Bitcoin Core that could serve, like Electrum server or something like that. So that work's been going on for a while. And then more recently, myself and another contributor, we started a module for libsecp, which Ruben mentioned earlier. It's the cryptography library that we use in Bitcoin. And so we started writing the module for libsecp because the idea there is it's going to be as efficient as possible. And with silent payments scanning, we've mentioned the computational overhead. So we want to make sure that there's an option out there that just nails it and like is as efficient as it can be. So we've been working on that. And also with cryptography, you don't want people out there rolling their own crypto. And silent payments is this tricky one where, it is just like application layer wallet stuff, but it's also got some cryptography in there where we're doing elliptic curve Diffie-Hellman, we're doing some key tweaking, and we don't really want to just be like, good luck, everybody. So the idea with the libsecp module is we can give this very high level safe to use API for wallet implementations where they don't even really need to know the cryptography underneath, and they can just use these high-level function calls to do it. So that's what I've been working on. There was another group that started working on like a Rust silent payments library that I was chatting with, and then they've been working on a light client called Donation Wallet that uses BIP 158 and silent payments. I think that's on Signet right now and testing. And then Cake Wallet kind of came out of nowhere, and one of their developers reached out and was really excited. And for Cake Wallet, I think it just clicked for them because their users are primarily, they're a multi-coin wallet, but I think they kind of target Monero and Bitcoin. They have a version of Cake that only has Monero and Bitcoin, and they're kind of more plugged into what those communities are doing. So they were like, oh, this is great. This is the user experience that our Monero users want. They already have like the Monero, I forget what the name they use, but they're basically stealth addresses. And what's funny about the Monero users, their light clients already have to sync. They have to download the way that the stealth addresses work in a Monero. They have to download the blocks and scan. So they were like, I don't know why everyone's complaining this isn't going to work for light clients. This is how it works in Monero, and it seems like yours might work even better. So this is super exciting. And they kind of ran with it, and I was chatting with them. So they have a public beta right now that you can use on Android and iOS that has silent payments as a light client, right? Because it's the Cake mobile wallet. That's usable. That's what I've been using. I think it's pretty awesome. I've been pretty happy with it. And then you mentioned, or maybe you mentioned Silentium. There was like another one that kind of popped up as a progressive web app that was also connected to like an indexing service. The progressive web app was pretty cool, but I don't think it's performant enough. I was playing around with it and testing it, and just kind of further convinced me of the need for the libsecp module because they were doing the cryptography part in TypeScript, and it just wasn't fast enough. So very quickly, you could play with the wallet, but then if you went a couple days without scanning, it kind of felt like it was struggling to catch up. But then there's been a few others out there as well that have been playing with the idea, and interestingly enough, everybody kind of is focused on light clients right now, which is funny to me because it's kind of a no-brainer if you're a desktop wallet or a full node. But on the implementation side, I'll mention this as well, because I think this is really important. And this is kind of a call to action for everyone out there. One of the things we tried to take into account with silent payments is that whenever you're introducing a new address format or a new protocol, what you really want is broad sending support. So using Taproot as an analogy here, Taproot goes out and exchanges won't implement Taproot support. And rightly so, because there's no wallets that can use it. So, an exchange says, hey, we support, receiving to a Taproot address. And it's like, yeah, but like none of the wallets in the ecosystem can even parse a Taproot address. So what's the point? So we wanted to try to get ahead of that and be like, right, when we design silent payments, let's separate the sending and receiving. So you can implement just sending without needing to implement receiving. And let's try to make the sending as easy as possible compared to receiving. So that would be my call to action to people out there. And I think Blue Wallet has kind of started looking into implementing sending support, because if we have a lot of wallets that are doing sending support, that's a signal to other wallets that it might be worth me to do the engineering to enable receiving support. And also any wallet that does have receiving support immediately becomes more useful, because there's lots of people that can send to that wallet. The nice thing too about sending, everything we've talked about with trade-offs, computation, more bandwidth for light clients, none of that applies to the sending side. You basically have to parse a new Batch32M encoded address, like a Taproot address, and you need to do some of the cryptography side to send to the transaction. But whenever we talk about trade-offs and other things like that, I want to make sure that's clear that we're talking about the receiving side.
Gotcha. Okay, great. And so if you could just kind of walk through, like, just at a very simple level, what does it look like for the user, right? Like, they just generate their own, like, let's say you have a Bitcoin wallet and it's already connected with your own full node. What would it look like? Like, you generate an SP code, and that can represent as a QR, and that's what you show people. And anyone who has silent payment sending support can scan that or copy paste the code, and that's it. That's the rough flow, right? That's what it looks like.
I mean, that's pretty much it. I mean, I would say even hopefully it's a little easier. If we think of like a Taproot address, it has that BC human readable part, which indicates it's a Bitcoin address. Then we have the separator 1. Then we have the letter P, which indicates the version. And then the rest is Batch32M encoded. Silent payments follows the exact same thing, where we use Batch32M encoding, which is the one that Taproot addresses use. Instead of BC, we have a new HRP, which is SP. And this indicates, this is not a traditional Bitcoin address, it's a silent payments address. We have the separator 1. Then we have a version. We're on version 0 of silent payment addresses, which is the Q. And then you'll see a long string of Batch32M encoding. What's in that, tying it back to the Taproot address again. In a Taproot address, that string of characters that you decode is a public key. In silent payments, we have 2 public keys. And those 2 public keys do not represent a script pub key that you're going to send some Bitcoin to, like they do in a traditional address. They represent instructions on how to create a Taproot script pub key. So basically, you read the you want to receive, you just generate this address. It looks like a longer Bitcoin address. You post a QR code somewhere. My wallet supports sending, scans that, reads it, recognizes the SP. Oh, this is a silent payment address. Gets the 2 public keys from the address, and then uses those public keys and the Diffie-Hellman cryptography that we've talked about to create a Taproot script pub key for you, the recipient, that then goes into the transaction. But from like a user experience level, it's really just, I see something that is a silent payment address, I scan, I send to it. And for me as a receiver, the flow on like Cake right now, you pull it up and you go to the receive page and they have an option there, a silent payment address, and you pick that one. And then you could keep reusing it or give it to someone with it being safe to reuse.
Yeah, I mean, the flow is no different from just having a single Bitcoin address and reusing it all the time, but not losing your privacy. That's essentially what it's going to be like.
Yeah, and so this would be,
since we're talking about the flow too, where from the sender side, one very different thing in the flow now compared to Bit47 and Bit351 and everything else is, I see a silent payment address, I send to the silent payment address. We're done. One transaction. Whereas in any of these other proposals, it's usually, I see a payment code, I make some sort of initial notification, which can either be transmitted out of band but then I need to make sure that the recipient has it, or they're not going to be able to find my subsequent payment.
That's not an option, essentially.
Yeah, I mean, yeah, but like more just the arguments that people have used. In practice, it means you need to make an on-chain transaction. So I want to, Stefan, I noticed you post your new code. If you're not using silent payments, that means when I pay it, I got to pay for a full on-chain transaction, pay the fees, wait for confirmation. Then once it's done, then I can send you a payment that you would actually find. So I think from the sender side, we're talking about a pretty huge step up in the user experience. And then we're offloading, maybe the degradation in user experience to the recipient, where now the recipient has to do the scanning.
Yeah, and hopefully that will also help adoption, right? Because I said it in the beginning, but I really think the sender side UX needs to be as simple as possible, because that's what you need for adoption. You need everybody to implement a sending support. And then for receiving, as long as there's one good wallet out there, everybody who wants to receive silent payments can just start using that wallet and then receive your silent payments on there. But you want everybody with existing wallets to be able to send money to you. And that's really what we need. I think literally sending support, relatively easy, and the thing that we need to spur on adoption. So I think adoption hopefully is going to be sort of similar to how Taproot addresses are in use now and supported by a lot of wallets. Not all wallets, obviously, but that's what I'd say.
Yeah. Okay. And now let's talk a little bit. You touched on this before around light client support. What does that look like?
Yeah. So that's a good one to go into, because earlier on you also asked about Electrum. And I think one of the things to sort of realize, and the thing that we realized as we were working on the BIP, was that a lot of wallets take shortcuts to make the user experience better, like client wallets. And those shortcuts generally don't favor privacy, right? So you end up with, and we've seen this also with a lot of BIP47 wallets, where you end up querying a server about your addresses, and then that server learns everything about the stuff that you're trying to keep private in the first place. So your threat model, okay, so you're not on chain, you're not revealing stuff, but to a single server that you're connecting to, you're still leaking all your privacy. And so the obvious model, and I think the one that always works, and that includes silent payments too, is just connect to your own full node. Right, run your own Electrum personal server, have that do everything that you require, and that just functions. And for silent payments, that would be no problem either, and that would work really well. But the tricky thing is, how do you do it without running your own full node? And that is, I think, the part where either you make privacy shortcuts, or you got to have a wallet that does a lot of things right, and that includes something like silent payments. But also implementing BIP 158. So you don't have to. So with BIP 158 specifically, you can when you have an address that you're interested in, you can basically check a filter to see, hey, is this a transaction that might be in this block, and then you sort of get an answer that is probably or definitely not. And if the answer is probably, then you download the block and you check. And so what ends up happening is that instead of you leaking, hey, I wanted to know information about this specific transaction, you only leak, hey, I'm downloading a specific block and it may or may not contain a transaction I'm interested in. So it sort of gives you a good anonymity set. And the big downside, and the reason why a lot of wallets haven't implemented this, is because it ends up requiring downloading more data, doing more work on your phone, and that is a slight hassle for the UX, because now the wallet has to maybe tell the user to wait a little bit, or have the user press a button and say like, hey, check the last couple of blocks now, or do it when you connect on Wi-Fi, or something like that. And so if you want to be really bandwidth preserving, then losing privacy is a good option. But if you want to maintain your privacy, and you still you're willing to sacrifice a little bit of user experience, right? Like, it's not going to be like 100% smooth, but it will be pretty good still. Then you need something like BIP 158, and silent payments slot in there really well. And we have essentially a proposal, or a design for allowing people to do their scanning, so checking whether or not they received a transaction by essentially receiving a bit of metadata about every block. And the metadata is essentially for every transaction, someone who runs a server and is willing to create an index for silent payments will basically take every transaction, generate a 32-byte number, and give you those 32-byte numbers if you're a light client. And then you can use those to generate essentially what are outputs that you think might be a payment to you. And that is what you check the filter with. And so, like, long story short, essentially, you download a little bit of extra data. With that extra data, you can do all the scanning yourself, and you still aren't a full node. And that is sort of what we've achieved here. And one nice thing about this is that we have support for cut-through. So essentially, if a transaction has been fully spent, then you know it cannot be a payment to you, or rather, it's not money that you currently own, at the very least. So we also have a sort of a mode where you skip those transactions, and that cuts down in bandwidth significantly.
Yeah, and just maybe to take a step back, I think it's really important that we clarify, like, what is a light client here? Because we sometimes throw that term around and someone's like, oh, well, a phone is a light client. And I would disagree. And I would say any situation where the user is not running their own full node, they are in a light client. And we've used terms like SPV before, things like that. So basically your choices are, you can run your own node at home on a Raspberry Pi or whatever. And at that point, silent payments UX is no different than anything else. There really are literally no trade-offs, right? Because I mean, the ECDH that we're doing in silent payments is roughly the cost of verifying a signature. It might even be less, but like as a ballpark, that's great. So your node is already validating every single transaction and checking the signatures. And now we're asking that node to do one more additional signature check, roughly, to see if this is a payment to itself. So if I've got Blue Wallet or any phone wallet that lets me connect to my own personal Electrum server or full node, I'm just giving the scan key to that server, being like, you do all the work for me. Only tell me when you find a transaction, whether it's in the mempool or a block. Now we get this amazing UX. I've got my spend key on the phone, got my mobile daily wallet. And this is the scenario that ideally we want everyone to be in, because when you're running your own node, you're doing your own verification, which is important. And you also have the best privacy that you can possibly have, even when it comes to broadcasting the transaction and all these other things. Now, if you can't run your full node, you now have two options. Use Bitcoin non-privately and in a more trusted way. And by trusted, I mean like the server just goes away and now your wallet doesn't work anymore. And non-privately, because you as a phone cannot download and verify blocks and transactions, so you're asking some server to do that for you. And within the spectrum of options that we have today, there really is no, in my opinion, and maybe this is a hot take, but there is no private mobile wallet out there. All of these wallets are using non-private backends like Electrum servers or something similar. Now, BIP158 was kind of the promise of like we could build more private light clients, but people have been slow to adopt that for various reasons. And one of the big ones that comes up a lot is just bandwidth. Like, well, the phone has to download more data. And to me, I'm like, I agree with you, and that kind of sucks. But I would view it more as, if you're getting privacy, I'm downloading less bandwidth than I would need to run a full node. Like substantially less data than I would need to run a full node, even in like a pure BIP158 world. So then it's really a question of like, I mean, run a full node if you really want privacy. If you can't run a full node and you still want privacy, you're going to have to make that trade-off with bandwidth. Now, if you want a phone that, is everything except custodial, which is not private, trusting a server, you can certainly do that. But that model isn't super interesting to me, at least in like building like a mobile backend or a light client. So in terms of where we are today, let's take Cake Wallet as an example, because they're the light client that's actually implemented. They forked Electrum RS, the Rust one, based on some work that myself and a few other developers were doing, and they modified it to where the Electrum server is now running an SP index. So every transaction that goes by, it summarizes the input pub keys of the transaction and stores them in an index. It also keeps track of, for these transactions, does it have any unspent outputs? If it doesn't have any unspent outputs, it doesn't give it to clients. So that was the cut through that Ruben was mentioning. So the mobile phone connects to the server and it says, hey, give me all of the tweak data for transactions that have happened since I last scanned, so long as they still have unspent outputs. And the Electrum server then sends all that tweak data to the phone, along with kind of a simplified block, or one of the terms we've used is like a simplified UTXO. And it says like, all right, here's also, if you end up finding a payment that belongs to you, here's all the data that you'll need to spend it. And so it just kind of sends this all in one dump, and it's at the block level, right? So again, the server only learns, hey, this client was interested in a block. I don't know if they found anything, and I move on. And so Kate downloads that data. Then on the phone, it does the ECDH checks with each of the tweak data, and then uses that against the outputs that it got. So it's not using a BIP158 filter at all. It works reasonably well. It's going to be more bandwidth, and there's that time to wait to sync. But the nice thing is, because we're taking advantage of cut through there, the amount of data that you have to download does not scale linearly with the amount of time since your last scan. So if I scan on January 1st, and then I wait a whole month to scan again, I do not need to download a whole month of Bitcoin transactions. And this was, I think, the problem that Monero was running into with their stealth addresses. The longer the phone was offline, the more data it had to download, and then that very quickly gets into something that's just unusable if you've left your phone off for a month. Whereas with silent payments, if I scan on January 1st and then I don't scan again until February 1st, every transaction that was created and then had its output spent in that time frame, I no longer have to scan. I'm completely unaware of. So really, when I'm scanning on February 1st, I'm saying, give me all of the tweak data for transactions that were created after January 1st and still have unspent outputs. And so I think this gets us into something where like the UX isn't great, like in the sense that we're just going to have to download more data. But really, we have this nice feature where it's about as good as it can get, because now the longer you stay offline, you're really approaching like a more constant level of data. It doesn't really go up or down, which is kind of nice, a nice property.
Interesting.
Yeah.
To mention,
So maybe one more thing to add is also one downside compared to the wallets that give up privacy is that you cannot really check the mempool, so you don't see immediately when you receive the payments. And that's the type of thing where I think a lot of newbie users, like, they sort of expect a certain level of service, and ultimately, like, a wallet that really guarantees your privacy will never give you the full UX that you would desire. Like, the ideal UX is not going to be equal to the best private wallet out there. And so I think we have a lot of good UX wallets out there already. And now it's sort of the question we were trying to address is more like, how do you create the best possible UX for a wallet that still maintains your privacy? And
Yeah,
that is that's been very interesting.
Yeah, fair point. Back to the show in a moment. This show brought to you by CoinKite.com, the creators of the best Bitcoin hardware security devices, such as the Cold Card Mark IV and the new Cold Card Q. Now, we use Bitcoin hardware security devices to keep our keys offline, our private keys offline. Now, the way these work is you can do that setup, write down your 12 or 24 words on the seed word cards, and keep that secure. Now, you can use this device to interact with the Bitcoin network using software such as Sparrow Wallet, Electrum, or Vector Desktop, or Nunchuck as a few examples. Now, you have a range of security features that you can use with these devices, such as passphrases, you can use seed XOR, or my favorite is multi-signature. Now, if you're starting in a basic way, just start with the device and the USB-C cable, plug it directly to the computer and use it that way, and then later improve your setup. But I believe these devices are great at helping secure your coins, especially as you start to migrate up into multi-signature security. But don't be disheartened or don't be scared away. They are accessible, and I think you actually do learn about Bitcoin in the process. So to get yours, go to coinkite.com, use code Livera to get a discount on your cold card. This show also brought to you by mempool.space, the leading Bitcoin and blockchain visualizer. I use it all the time when I'm checking transaction fees and trying to understand what is the state of Bitcoin's mempool. You can search transactions, historical as well as unconfirmed ones, and also see a great way to visualize things across the Lightning Network, Liquid, mining, and so much more. Also, for those of you with an enterprise, they offer a mempool.space enterprise program. So for those of you as part of that enterprise program, you might want to get increased API limits, and you might want to have increased access to the team in terms of feature requests. You might want to have special branding in terms of how your custom instance of mempool.space looks. So to sign up for that, go to mempool.space/enterprise. The lead sponsor of this show is Swan.com, and Swan has a mission to onboard millions of people into Bitcoin. I also work at Swan, helping on some educational content for the team. Now, the team have also put out a new version of the Swan Bitcoin application, which is available on your smartphone, whether it's Apple or Android. Now, this app has a really fast onboarding experience. It's now just a few minutes to go from zero to Bitcoin. So if you are standing there with your family or friends and you might have been having trouble trying to get them onboarded, well, try this now. Recommend Swan Bitcoin. And you can do this while you're standing next to them. They can click through, and most of them will be able to set up and do this in just a few minutes. Also, the team at Swan have rolled out a new promotion. There are 0 fees on your first $10,000 of Bitcoin buys. So this is a great way to go from zero to Bitcoin, and in a guided and managed way. So reminder, go to your App Store or Play Store and search Swan Bitcoin to get onboarded with Bitcoin today. And now, back to the show.
We have a spend key and we have a scan key. The word view key is like basically an alternative for scan key. Essentially, there is a key that allows you to check whether or not you received the payment, and that is the scan key. So with the scan key, you can imagine you have maybe you have a hardware wallet and you have a full node that you're running. And the full node controls the scan key. And so with the scan key, the full node can check every transaction and see like, oh, was this a payment? Yes or no. But then when you want to actually spend it, you need the spend key. And so this allows us to sort of separate out the concern of, well, how do you find the transaction and how do you spend the transaction? And the nice thing about that is that maybe your scanning is occurring on a device that is not as secure as a hardware wallet. So then worst case scenario, if you lose your scan key, if somebody hacks you or something, then they will be able to basically undo the privacy gains that you had, like by seeing everything, all the transactions that went to you, but they will not be able to spend anything. And so that's basically the reason why we have two keys like that.
Yeah, and if we go back to like traditional wallets where we have XPUBs and XPRIVs and everything like that, I think the best analogy here is, I'm actually ripping this analogy off from Reardon Code. He had a great tweet about this that I've been super happy with the description. Previously, we had a 2-level wallet. You had the XPUB and the XPRIV. And the XPUB was the watch-only wallet, right? That was the way to view your transactions. And the XPUB is what you would do when you're querying the Electrum server and be like, hey, do I have any transactions? And the XPUB is also what you would give to people if you're like, hey, instead of texting me every time, just use my XPUB. And so they were kind of tied together. Now with silent payments, we have a 3-level wallet. We have the address, and the address is, here's how you send me money. Then we have the scan key, which is the watch-only wallet, right? The XPUB. And then we have the spend key, which is the XPRIV. So the spending instructions, the watch instructions, and the sending instructions. And this 3-level wallet design, I think, opens up a lot of really cool design space that we haven't had before. And so, like Ruben mentioned, I can have my spend key secured in cold storage and somewhere that's never connected to an internet device. Then I can have my scan key on my Bitcoin node or my Electrum server or whatever. And if I lose that scan key, it's the same as if I leaked my XPUB or my watch-only wallet, which is not great, right? I lose my privacy, but I do not lose access to the funds and I can still spend the funds. The other thing that's really nice, if I give you my XPUB and I give Ruben my XPUB, you can send payments to me and Ruben can send payments to me without interacting with me after that first interaction. But you guys can also see each other's payments. And you can be like, oh, well, it looks like, someone else has been sending Josie money. With silent payments, because we now have this 3-level design, the address is separate from the viewing. So I give my silent payment address to you and I give my silent payment address to Ruben. And you guys can both send to me without seeing what the other person is doing. So that's kind of the overview of like the view and scan key, the scan and spend key, but also kind of how it opens up this new design space for wallets.
Yeah. Okay. And so the other big win that we should elaborate a bit on this as well is I think it's important just to explain for listeners who maybe aren't as into it how much address reuse there is, just in general, right? Like, just I think that's if we zoom out, that's really what this is, right? If we got broader adoption of silent payments, we would just see a lot less address reuse in general. And that's probably a big privacy win that people might not initially grasp. Do you guys want to elaborate on that?
I think one of the reasons they don't grasp it is because we think, oh, I don't reuse addresses. So all those poor suckers over there are reusing addresses. And I think what people don't understand is address reuse hurts everyone's privacy. Even if I'm not reusing addresses, but you are reusing addresses, that's creating these clusters and things on chain that people are using software to make, questionable claims that aren't even really based in real techniques and science, but just the fact that we have these clusters and these pathing, people can kind of make claims about, this was an exchange versus not, etc. And so the biggest offenders here are actually exchanges. Like, they're the ones that are reusing the most addresses. And I don't blame them, because if you're talking about normies and you're telling them you got to use a fresh address every time, and then, every time I go to Coinbase or Kraken or whatever, and my deposit address change, I'd freak out. I'd be like, oh, wait, am I getting hacked? Is this the right address? So it makes sense that they do this. And this is where I think I'm really excited about silent payments, because I think it does have the potential to actually move the needle on-chain address reuse by just having a superior UX and not costing the users any additional fees to use it. And that kind of indicates we might actually see broad adoption of this. So the real end game is to get exchanges to adopt it, to where if you're depositing to an exchange, you're depositing to a silent payment address that is unique to you, the customer. And we didn't talk about this yet, but labels is a pretty important part of silent payments that makes that possible, where the exchange could hand a silent payment address just to you, that they would know when that address is paid that it was a payment from you. Also, automatic withdrawal. So there's a lot of these DCA services. I think Swan has a DCA
Swan,
to it. Yep. So perfect use case, right? Now, me as the user, I say, I want to auto withdraw from Swan using my silent payment address. And this is better than the XPUB version of that, because if I'm auto withdrawing from Swan with that XPUB, it's got to be an XPUB specific to Swan, and I can't use it anywhere else. And then I have to, manage XPUBs for other people. Whereas silent payments now, I can have one hardware wallet, whatever, where I'm custodying these funds, and I can use that silent payment address everywhere. I can give it to Swan to be like, hey, I want to auto withdraw here. I can put it on my Twitter bio, whatever. So I think this is kind of the usability that, even if people don't care about privacy, it could move people to adopting a superior UX and something that they more expect from a payment system. And by doing so, we've Trojan horsed in the privacy by getting rid of the address reuse, because we've abstracted the on-chain address away from the user. Let's imagine for a second, adoption takes off, everyone's using silent payments. You would get to a world where people don't even really understand the underlying, they don't even really care. And I don't even think that they should, about what actually goes on chain. Now, we're the early adopters in Bitcoin. We understand the techs always talk about, what happens on chain. But if I send money through the fiat system to a bank routing number, I have no idea what's going on under the hood, and I don't care. And I think that's kind of a way where we win this privacy problem with address reuse, is we solve the UX problem for the user. We understand, why were you reusing addresses? It was a UX problem. Let's solve the UX problem. Let's abstract away the details of what's happening under the scenes, so then we can implement it in a very private way without asking you to care about it. And this is where, we don't get these opportunities a lot in privacy. It's usually you need to pay more for privacy, or you need to use more complex protocols. And silent payments was one of these unique ones where it's well, wait, what if we just solved the UX problem for people in a way that's incentive aligned? And then as they adopt it, because of the UX benefits, then the privacy gets better, because we're seeing, less address reuse. So that's, pie in the sky version is silent payment addresses in every exchange, because then I think that would make a huge dent in the on-chain address reuse that we see.
Yeah. Great. So yeah, as you were saying, it's the combination. It's sort of this marriage of a privacy improvement with the UX improvement that's actually going to more likely to get it adopted. So one other area, as you were touching on, if you guys could explain the labeling concept with silent payments.
That's definitely something. So that's something that came up like after I wrote up the initial specification and the idea. The labeling thing was always just sort of like, it was something that people were mentioning as a downside. Like, well, what if you actually want to know who is sending you the money? Because like with silent payments, by default, you don't really know who is sending. And so I thought about that, and the labeling thing is what I came up with. And so one naive way to do it is creating a new silent payment address for everybody who's paying you. But if you do that, that is basically it blows up your scanning costs, right? Because for every user, you have to now scan every transaction. So that's just not scalable at all. And so this is sort of a middle ground where, because like with a new silent payment address, you could essentially, you wouldn't even be able to link the identity, right? Like I could generate two silent payment addresses, and I could pretend to be two people online, and there would be no link between the two. But with labels, essentially, I came up with like a neat trick to allow you to basically add a little bit of extra data into the address. And so the way this works is like we mentioned earlier, we have a scan key and a spend key. And basically, we tweak the spend key in a deterministic way. And on-chain, when you're checking for payments, you basically do an additional check to see, hey, which spend key did this money go to? Then depending on which spend key it went to, it tells you something about the recipient. So you could generate essentially what is the equivalent of a different spend key for every user on an exchange. And then the exchange, when they're scanning, they would have to do one additional calculation, which can be very cheap because it's basically just a database lookup, to check and see, okay, which spend key did this money go to? And so this basically allows you the sender to communicate something extra to the recipient. That the recipient, includes this data basically in the address that they give to the sender prior to receiving money. But this is essentially how it works. And the exchange use case is just one of them. But you could also have a use case where, let's say, I'm on Twitter and I'm on Mastodon, and I have two silent payment addresses on there. It's clear to everybody that they're the same. The silent payment address belongs to the same identity to me, but the spend key will be different. So basically, the way it will look is the first half of the address will look exactly the same, and the latter half will look slightly different. And now, when I'm receiving money, I can see like, oh, these are Mastodon users that were paying me, or oh, these were Twitter users that are paying me. And so it gives me a little bit of extra information. And so that's a really neat feature that sort of like allows us to kind of have the best of both worlds, right? If you want perfect privacy and the sender doesn't want to reveal anything about themselves, then they just use your main silent payment address. But if you need a use case where you need to learn at least something from the sender, then you can utilize this.
Okay, great. Now, contrasting, or let's sort of say when you're adding in Lightning to this picture, right? Now, obviously, they're different protocols, right? We're dealing here with on-chain payments. So generally speaking, these are larger payments, whereas your smaller ones, you do that on Lightning. I guess that can make things confusing again for, if people just want to have like one QR code that they put somewhere to take their donations, where maybe currently they might use a Lightning address, or maybe in the future that would be a Bolt 12 address if they're dealing with smaller payments, let's say. So do you guys have any ideas on how to sort of square that circle? Are we gonna have contact lists in our in our apps that sort of talk about, oh, this is Josie's Bolt 12 code for small payments, but if I'm doing a big payment now, we need to deal with his SP code, his silent payments code? Or do you have any ideas on how to marry the two?
Yeah, and I kind of hinted at it earlier. The silent payment address is abstracting away what's happening on chain, and I think eventually we should get to something that's abstracting away what's happening on Bitcoin from the user. And so, previously we've had unified QR codes with BIP21, so I think that's like kind of the first most natural place where you have this URI that presents a couple different options, and there's one single QR code, and the sending wallet reads that QR code and then picks the one that either they're able to or they prefer. So that's kind of the first step towards that. Even more exciting, Matt Corallo, the Blue Matt, proposed a BIP a couple months ago that was like human readable.
The human readable names thing for Lightning. Yeah.
Yeah. So this is really exciting. I'm super stoked about that because now you have, without getting too many into the details, it's using DNS SEC to make it like more secure, but you have this way to have like Josie at josie.com, whatever my domain is, or, you know, maybe I've signed up with a wallet provider, josie at bluewallet.com or josie at cakewallet.com. And then when you want to pay me, you just send money to josie at blahdomain.com, and the wallet is doing some lookup to get the payment instructions for me. And that payment instruction is returned in some sort of unified, you know, either a BIP21 URI or a unified QR code or whatever we want to talk about. And then the wallet makes a game time decision. What's the best way to pay this person? If the person communicates a Bolt 12 static offer and I can understand a Bolt 12 static offer, I'm going to use that. If the payment includes a Bolt 12 static offer with a fallback to a silent payments address, then I'm going to use the silent payments address if I'm not a Lightning wallet, et cetera, et cetera. To the user, doesn't matter. And we've just kind of built this nice layer on top of it, which gets away from this, like, you know, you've seen these donation pages in Bitcoin where it's like, here's my Taproot address, here's my Segwit address, here's my Bit47 payment code, here's my Lightning, you know, address, here's my Bolt 12 off. And you're just like, oh my God, like this is, you know, for us that love the tech and, you know, we're like, oh, this is so cool. Look at all this, you know, whatever. For a person who just wants to pay you, it's mental overload. And I think we should move away and solve that as much as possible. The thing that makes me really excited is up until we had BIP 352, up until we had silent payments, we didn't really have something that would just go right along with a Bolt 12 offer super easily. Like had we used, you know, BIP 47 or one of these other ones, there would have been this weird, you know, I make the payment, I wait for an on-chain transaction, there's weird setup
the
ceremony.
notification transaction style just limits what your possible, limits the possibilities.
Like, then it all came together, and you know, right at the same time that Matt was writing this DNS names resolving BIP, and then we were finishing the silent payments BIP, I was like, holy shit, it's all coming together where it might actually be possible to have this super clean privacy by default UX on Bitcoin, and that's what I get most excited about. And
so speaking as well broader, I think there's this idea, and I think you and I were talking about this kind of on Twitter or X before. We have to kind of get people away from the silver bullet mindset, right? This idea of just this one technology, this one thing. I load the gun, and that's it. It's more like we need multiple tools. Maybe it's like silent payments and pay join adoption and Bolt 12 and human readable names, and you kind of pull these pieces together, and now we're starting to answer the question, right? And I think this comes to the other point, which people might have seen. Edward Snowden sort of came out making some comments saying, and I kind of disagree with a bit with his framing, but the way he framed it was kind of like, I've been telling these Bitcoin developers for years they need to pull their finger out and start focusing on Bitcoin privacy on chain. And, it just kind of, it seemed a bit out of touch with how actual Bitcoin works. And first of all, Bitcoin developers are not a monolith. There are many of them. They disagree. So it just kind of seemed a bit weird to me. But I'm curious if you guys have any thoughts in response to that, and, what is the realistic path forward for Bitcoin privacy?
Well, one thing I think that's always important to sort of realize and think about is that, like, if you take something like Monero, they use their transactions are a lot larger, and the CPU is like you have to do a lot more work. You have to download a lot more data to get the same amount of the same number of transactions. So it's not like you get it for free. So that's the first thing to realize. You're gonna have like you would have the equivalent of maybe a 100 kilobyte block size if you wanted to have Monero's level of privacy. It might even be worse. So that's sort of one thing to keep in mind, that there's a cost to it. And there are other costs too, of course, where if you don't see the actual the amounts on chain, then that can lead to problems if you have some kind of bug in the system. So there are a lot of concerns there. I do think it's nice, like in theory, if we could have more privacy on chain on layer 1 in Bitcoin with zero cost, let's say, right? Like no trade-offs. then the answer I would give is yes, let's do it, right? So I don't think anyone would be against it necessarily. The question is more like, is it worth it? And do we want to essentially allow for fewer transactions, but have them be more private? And I think the answer to that might be a yes, if it turns out that there's no possible other way of receiving privacy, right? If you can't get privacy any other way than just having the base layer be private, then maybe that is what we would have to do. But there are a lot of other options out there. There's CoinJoin. There's a bunch of research into like layer 2 protocols that might help. We have things like Arc, for instance, that is inherently trustless, but also works as sort of a mixer. So there are a lot of options out there. So it's not necessarily a given that we need to make base layer sacrifices to get privacy. And so that's, I think it's a difficult question to answer ultimately. But I think that's at least what's good to keep in mind. Like it doesn't come without trade-offs.
And I would even take a step back from the privacy framing, right? And more just where my, I guess, strong theory of the case, like how I think the world should be, comes less from a privacy standpoint and more from an engineering standpoint of, when you're designing something, I think you should do one thing really well and you should play well with others. Those are the two. And, to put those in more technical terms, it's like the Unix philosophy. Small tools that do a task really, really well, but also compose well with other small tools. So composability is kind of that play well with others. And I think just in general, privacy is going to be better when we stop trying to build the silver bullet or, the Rube Goldberg machine that will do everything. And we look for ways to identify what's the problem here. Let's solve this problem super efficiently, as elegantly as possible, and then let's make sure it composes well with other things. So silent payments is an example. It was just to tackle this one problem of interactivity with payment instructions and getting rid of the bad incentive to reuse addresses. That's all it focuses on. And then people were like, oh, well, the on-chain, if I consolidate the UTXOs, I'm like, yeah, you're talking about spending privacy. That's a totally separate problem. And then they're like, oh, no, well, Bit47, solves that. I'm like, no, it doesn't. Bit47 is in Samurai Wallet, and Samurai Wallet combines a lot of these tools together, which is, I think, the best way to do it, right? Keep the protocols separate, distinct, and then, at the application, the mobile wallet, the full node, whatever, now you combine these things together and you get a more comprehensive privacy solution by stringing all the little tools together. And I think that's just the right approach, whether you're building for privacy or anything else. And, I think, we've talked a lot about Bit47 because it's the one that had the most adoption, but I'll use that as a cautionary tale. I think one of the mistakes they made in the protocol with Bit47 was it was really designed around this merchant customer use case. And it says it in the BIP, and maybe privacy was even an afterthought, right? It wasn't really meant to be like a private protocol, and that's why they made certain decisions, like every time you make a payment in Bit47 and establish a channel, you're sharing the payment code of the sender. Now, from a privacy standpoint, I'm like, that's a horrible idea. Like I would, if I put my payment code in my Twitter and then I want to go use my Bit47 for something where I don't necessarily want the recipient to know who I am, and then I share my payment code and then they know who I am, and maybe people aren't aware of this. It's just a very bad decision, I think, to make in a privacy protocol, but it's more because they were trying to do a bunch of different use cases. They're trying to make it work for a lot of different things. And so the analogy with silent payments is silent payments does this thing really well, this non-interactive, fully private. And then if you want that like customer merchant refunds, well, then you can add labels on top of it and you can, do whatever. And if you wanted contacts, right? Because some other people were like, oh, why is it a Betch32 address? Why isn't it, like a simple, I'm like, okay, that's something you can add on top of silent payments. Expiration dates came up when we were talking about silent payments. Someone was like, look, if it's going to be static, it needs an expiration date. And I'm like, that's a separate problem, right? That's address data becoming stale over time is a totally separate problem that needs a different design space. Now, I'm not saying that's not important. I'm saying we should have a silent payments protocol that does reusable addresses really well, knocks it out of the park, and make it composable with something that does expiration dates or revocation really well. So, you mentioned PayJoin and some of these other things. I think the perfect solution for privacy is we keep as developers, as a community, picking the problem that we have domain expertise in, that we really care about, and coming up with a really simple solution to that problem, and ensuring that that really simple solution operates well with other solutions. Because the best privacy isn't going to be this be-all, end-all BIP or wallet or protocol, but it is going to be a wallet that can do silent payments and pay join in a way that, they interop together. A lot of the design in silent payments went into making sure that we were going to be compatible with CoinJoin. So rather than build like the silent payments CoinJoin protocol, be like, hey, let's build silent payments, and then let's figure out and let's make sure that we don't back ourselves into a corner so that this is composable with CoinJoin. And I think in terms of privacy and engineering, that's the philosophy that we more need to take, of like simple problems, simple, elegant solutions, and then combining them together.
Yeah, really well said there. And I think the other thing, the thing that I was thinking about as well is, so let me put it this way. The big thing with reusing addresses is you're giving the outside observer a starting point, right? That's like the big thing. You're just giving them the starting point. Now, of course, it's one thing. It's one thing if the exchange knows your coin, like at least where they sent the coins, because they're the ones who sent the coins to you, right? So they know that starting point. Put it that way. But an outside observer, in the case where you're not reusing addresses, they don't have a great starting point. They don't necessarily have a great starting point. And then from there, that's where the chain analysis kind of, okay, this hop, that hop, that hop. Now, to be clear, there's lots of heuristics, right? But probably the main one is the common input ownership heuristic. There's other ways in which your privacy can be impacted. Things like timing analysis, right? If you move a large amount of coins through at a certain time, maybe there's a timing analysis approach there. Maybe there's the internet level, the what IP broadcast the transaction, or what IP was asking for these transactions from the Electrum server. Oh, okay, now we've got you from the IP side, not the transactional graph side. So there's kind of all these components to it for somebody who wants to be private, and the reality is that you're, in most cases, going to have to pay more or kind of do more work to stay private. So I think it seems likely to me, if we had to kind of speculate a bit about where it goes, like let's say we got silent payment adoption. Let's say we got more pay join adoption amongst the wallets. So now the common input ownership heuristic is being undermined. So you're giving them less of a starting point, and now when you're spending, you're not kind of giving off clues about, exactly where those coins are going and whose coins belong to who, because the wallet clustering requires these heuristics to be able to do it. Now, to be clear, there's different heuristics, right? It's not just common input ownership. It's output type or input type. It's the ordering of the inputs. There's end sequence numbers. There's kinds of all these ways that people try to fingerprint different wallets. But I guess these are the ways to sort of take away the low-hanging fruit, right?
Well, and you've used the term heuristic multiple times because that's what they are, right? It's not a guarantee. Everyone's looking at all of these different, bits of entropy and trying to kind of pull it all together to get a fingerprint or a heuristic. And so I see a lot of value in frustrating the heuristic. Like that's all you have to do to really be effective. We don't need the be-all, end-all solution, which some of these like privacy at the base layer things kind of try to do. And instead, I think if we can frustrate the heuristic to a point where be like, hey, you can no longer accurately claim that because I can demonstrate multiple instances and a certain percentage of instances that are happening that go directly against your heuristic, it's enough to sow doubt in the heuristic that's being applied. And also, I think what you said about starting point is really great. It's really hard to get back privacy that you've lost in Bitcoin because there's a permanent ledger, right, that is replicated around the world, and everyone has access to. So I think, starting here and saying like, how do we make sure that from the get-go, you're not making horrible mistakes that will then be tracked throughout the rest is a really good place to start. And then when we talk about on-chain, I think really where we got to focus on is how can we make sure that there's enough ambiguity as to what's happening on-chain that even though you can see what's happening, you cannot make definitive claims about it, which is why tools like PayJoin, CoinJoins are really powerful in frustrating those heuristics because they give a counter narrative. The common input ownership heuristic says one person owned all these coins, and then PayJoins and CoinJoins come along and be like, that's not true. And I can give you plenty of examples otherwise. And if these things see wide enough adoption to the point where they're not costing the user more to use them, then I think we get into a place where a significant amount of transactions just don't fit the heuristic anymore. And it's something we kind of tried to think about in silent payments as well. Like silent payments, the BIP defines and says when you send to a silent payment address, you have to create a taproot output for them. And early on, there was some criticism about that. And they were like, no, you need to give the recipient the option to specify like a bit that says I want legacy addresses or whatever. And we're like, no, like if we have a choice to kind of lock down the optionality of how you use this protocol in a way that makes it more private by default, that's the right thing to do. Because eventually, if we continue to see taproot adoption and we see these spends on chain and we don't know if these taproot outputs are silent payments, lightning channel opens, or MuSigs or Frost, everything starts to look the same on chain. And that's really the world I think in Bitcoin privacy we have to keep pushing for. And anything we can do that kind of moves the needle toward that, I think we're going to end up in a much better place. Some of my early privacy work was around all of this like script type heuristics, and everyone was like, oh, you just got to match the script type of the change. And I'm like, no, you got to go all the way to the coin selection, and you got to manage all of this. And the more uniform the activity on chain becomes, the less and less of a problem some of these things are, and the solutions become easier and easier to build because you don't have to account for this giant matrix of all these different flags and fingerprints to worry about.
Yeah. One other area, I'm curious if you see any, in the same way, as you said, to the composability point, do you see, as an example, when Lightning nodes open channels with each other, is there something there, or maybe when Lightning nodes do like splicing in and out of channels, do you see any sort of applications to it there, or not really?
People have asked this. I would say not really. On the implementation side, so we talked to someone from who was working on core Lightning, and they mentioned, one of the annoying things about having XPUBs is state management. I have to do the gap limit, and I have to make sure that I'm not, handing out an address that I've already handed out, and that makes software more complex. And I would say silent payments is a very elegant solution to that, because it's like, don't worry about it. Like silent payments is a stateless protocol. There's no state management. You just hammer it with CPU. And so it's very simple, and you just hammer it with CPU. And I think from like a code, implementation standpoint, that's really attractive for some of these things, where instead of handing out addresses and stuff, they just have a static piece of data. That's a benefit, I would say. And the gap limit can just be really annoying. On the other hand, silent payments really shines with non-interactivity. Like that's really kind of what we were going after there, of like,
right.
This whole
Whereas
secure
Lightning,
interaction.
we're already talking to each other. Yeah.
Yeah, if you got interaction, and you can do this securely, and you've got all the infrastructure to do it, I don't see any reason to prefer a non-interactive protocol unless you're trying to further remove interactivity from your protocol. Now, I do think we should all be trying to get rid of interactivity as much as possible. It's complex as hell. It's the death of privacy. It's buggy, etc. So if there is an option where someone can replace something that they were relying on interaction with silent payments, then I'd say yes. But beyond that, I'd say, look, if you got interaction, just do what you're doing.
Yeah, totally fair. Okay, so I think we've covered a lot of stuff here. Obviously, there's probably a good spot to start wrapping up and summarizing. So let me just say we've spoken about a lot of things, but if we had to just boil it down to what are the key benefits, I see it as cutting address reuse and making it a lot more like a contact Bitcoin username. I think having that user experience win, right? It's not just a privacy win, it's a user experience win. I'd say those are probably the two focus areas for listeners who, if you're not that technical, you just kind of wanted to get a rough idea, what is this? What is it going to help us with? I think I would say if you're a listener and you are maybe in some wallet Telegram chat or Discord or something, maybe you can push them to say, hey, why don't you get silent payment support, right? And if you can at least start on that side, starting to kind of encourage your, communities to kind of push for silent payment support in terms of making the payment. And then eventually once there's enough payment support, then there'll be enough wallets and wallet developers who are like, okay, let me code up silent payment receive support. And then now we will start to see a world where donations become a lot easier and just kind of regular transactions become a lot kind of easier. And it would be cool if exchanges adopt this, obviously. So I think that's probably my high-level summary. Do you guys have any closing thoughts for people?
Yeah.
I think that's an excellent summary for one. Josie, you want to add something?
Yeah, so we've got a lot of activity on Delving Bitcoin right now. So we started a silent payments working group. It's anybody's free to join the working group and post there. And so someone had reached out to me and was like, hey, what are we doing for PSBTs? So they've started a discussion on how we're going to get PSBT support for silent payments. I think that's a pretty important one for wallets. I'm also working on a descriptor BIP for silent payments. So like, how are we going to make sure that silent payments, are interoperable between wallets in a really clean way? And I think descriptors are the best solution we have for that. So I'm going to be posting on Delving for that in a couple of days. We've got, so a lot of things that happened when we were talking about silent payments, all these people started building indexes. And so, we were using Nakamoto, which is a Rust library for BIP 158. And then someone else built something in Go called BlindBit. And then the Silentium wallet also has Silentium D as the index. So I was kind of watching all that happen and kind of pushed a few of these people to be like, hey, start a post on Delving. Let's start to standardize like a light client protocol. So that, if you build an index and I build an index, wallets can use multiple indexes, just like, the Electrum world we have today. So, to the developer community, I would say, look, if you're excited about this and you want to see silent payments happen, you just join the discussion. We want as much input from wallets as we can get. And there's still a lot of, doing all the implementation details. There's a lot of work there. If you don't really care that much, then yeah, just implement sending support. Because I think, the sending support is really important for adoption. I also think, there's the silent payments today, like getting it to work with everything we have today. Eventually, one of the things that I would love to see someone do, just because I've been wanting to do it, but I don't have time, is get some support for these personal servers. So we have the, Electrum, Fulcrum, things like that. To me, that's a no-brainer. Just add a silent payments index to that, have a user register their scan key so that, the index can scan for them. That would allow broad silent payments receiving support in mobile wallets today if those mobile wallets already support a user running their own server. So to me, that's like a really low-hanging fruit. Let's get something that works for the people who are using Bitcoin privately today, the people who are running full nodes, and then we'll keep working on the light client problem. But yeah, I would say get involved on Delving if you're in the technical community. If you just want to use silent payments, then yeah, talk to your wallet provider of choice and really push for the sending support over the receiving.
Great. Well, I'll put the links in the show notes for listeners as always. Josie and Ruben, thank you for joining me today.
Yeah, thanks for having us. It was fun to catch up.
I hope you enjoyed the show. If you did, make sure to give it a thumbs up and share it out there with your family and friends. Check out my website at stefanlivera.com, and I will see you in the Citadels.